Astronomers detect hidden moons orbiting Neptune and Uranus. Jupiter and Saturn need to step aside with their moon-hogging ways. The outer planets of the solar system have also been harboring secret satellites. Using ground-based telescopes, astronomers have discovered 3 previously unknown moons in the space around Uranus and Neptune, 1 orbiting Uranus and 2 around Neptune. That brings Uranus' official moon count to 28 and Neptune's to 16. Can you imagine? The moons have yet to be officially named, but in keeping with moon naming conventions for both planets, the new Uranus moon will be given a name from Shakespeare's works, and the Neptunian moons names from Nereid, sea goddesses from Greek mythology. The 3 newly discovered moons are the faintest ever found around these 2 ice giant planets using ground-based telescopes, say astronomer Scott Shepard of the Carnegie Institute for Science. It took special image processing to reveal such faint objects, he said. New moons, as in moons we did not know about before, are not rare discoveries in modern astronomy. As our technology and techniques for studying space grow even stronger, so does our ability to find small, dim things that were beyond our previous reach. In recent years, Jupiter and Saturn have dominated the moon race, while Neptune and Uranus have gone sadly neglected, a tale as old as solar system exploration, to be honest. The 2 outer icy planets are far from Earth, which makes them more difficult to travel to and more difficult to see with telescopes, which means our understanding of them is a lot more limited than the other 5 worlds closer to Earth. The flip side of this coin is that there are probably a lot more moons out there waiting to be discovered, as evidenced by the 3 newly discovered satellites. All 3 moons have wide, eccentric, and inclined orbits, which makes them harder to spot. These orbits are consistent with the capture origin snared by the planet's gravity and kept in a strange looping dance around it. The new Uranus moon, first spotted in observations using on one of the Magellan telescopes in November 2023, was confirmed by finding it in data dating back to 2021. It's been provisionally named S2023-U1 and is the first new Uranian moon discovered in more than 20 years. It's around 8 kilometers, that's 5 miles across, which makes it the smallest of Uranus's moons and one of the smallest known moons in the solar system. It has an orbital period of 680 days. The brightest of the 2 Neptunian moons, provisionally designated S2002 and 5, was first spotted by Magellan observations in September 2021, and then again in October, with follow-up observations in 2022 and 2023. Once S2002 and 5's orbit around Neptune was determined using the 2021, 2022, and 2023 observations, it was traced back to an object that was spotted near Neptune in 2003, but lost before it could be confirmed as orbiting the planet, Shepard says. It measures 23 kilometers, that's 14.3 miles across, and has an orbital period of 9 years. And finally, the smaller, fainter, new Neptunian moon was spotted in 2021 using the Subaru telescope. It's been provisionally named S2021-N1 and measures 14 kilometers, 8.7 miles across, with an orbit of 27 years around Neptune. The newly discovered moon suggests that Uranus and Neptune have outer moon populations in configuration similar to those of Saturn, 146 known moons, and Jupiter, 95 known moons. This suggests that the method whereby these moons were obtained is similar across all the giant worlds in the solar system. Even Uranus, which is tipped on its side, has a similar moon population to the other giant planets orbiting our sun, Shepard says. And Neptune, which is likely captured the distant Kuiper Belt object Triton, an ice-rich body larger than Pluto, an event that could have disrupted its moon system, has outer moons that appear similar to its neighbors. Capture may have been the first step, but the new moons fall into groupings of moons that have similar orbits as 2023 U1 falls into the step with Caliban and Stefano, as 2002 and 5 fits with Sao and Laomedeia, and as 2021 N1's orbit is consistent with those of Psamathe and Neso. None of the orbits are exactly alike, but the similarities suggest that each of these moon groupings could have started off as one whole moon that was captured by planetary gravity before breaking apart, each of the pieces then working out their own orbital paths. Can you imagine? If this is the case, there could be much smaller moons that we cannot yet resolve in each of the groupings. It's a discovery that constitutes one more compelling reason out of many to send a dedicated probe to the outer solar system. And this is on Science Alert by Michelle Starr. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.